Namaskar, my name is Aditya Ajmera, and in this lecture we are going to discuss a very important topic from the subject of climatology. This is the topic called Indian monsoon. So we have heard about monsoon from the farmers in the field to the MPs in the parliament. Everyone want to know how the monsoon will be for this year. Even the economists want to understand what will be the impact of Indian monsoon over the economy. And from the perspective of civil service examination, this is one of the most important topic, not just for the prelims, but also for the mains. So in this lecture, we are going to discuss how the monsoon forms, what is the mechanism of monsoon, and how the monsoon onset over the India. So we have the outline map of India. This is Tropic of Cancer, 23.5. This is 0 degree latitude, that is equator. And below it, we have the 23.5 degrees south, that is Tropic of Capricorn. To understand the monsoon, we have to understand what is the meaning of this word monsoon. So monsoon basically means the seasonal reversal of winds which bring rainfall to the Indian subcontinent. So how this happened? The primary reason behind the monsoon is the apparent movement of sun. How the sun changes its position, like during the month of December, we have the direct sun rays directly fall over the Tropic of Capricorn. So if the Tropic of Capricorn face sun rays at 90 degree angle, then the temperature will get increased. And this will result in the formation of low atmospheric pressure at the region of Tropic of Capricorn. Same here, we have during the December month, the northern plains face winter season, and this result in the high atmospheric pressure. So this is the time when we have the high atmospheric pressure, low temperature during the month of December. But when the sun rays changes its position, like during the month of March, the sun rays directly fall over the 0 degree latitude, that is equator. So this is the time we can say that the beginning of summer season in India. The sun rays start to climb up, move from Tropic of Cancer to the 0 degree equator from the December month to the March. So here we are going to discuss some basic concept behind the formation of monsoon. The atmospheric circulation, like during the month of March, we have easterly winds. These easterly winds also called as the trade winds. These winds came from northern and southern hemisphere and they converge at the equator region during the month of March. And this convergent zone here is also called as thermal equator, and technically we call it ITCZ, that means Intertropical Convergent Zone. So the tropical air, the winds at the tropical region converge at this zone, which we call it Intertropical Convergent Zone. So during the month of March, this ITCZ line we can see at the 0 degree latitude. But what will happen if the sun rays start to climb up at the Tropic of Cancer? This ITCZ line start to climb up. So during the month of June, as the sun rays directly fall over the Tropic of Cancer, this ITCZ line will also start to climb up and it will look like this. This is the line called as ITCZ, Intertropical Convergent Zone. So we have discussed the tropical air converge at the ITCZ. But if the ITCZ climb up at this region, then what will happen? These winds coming from the northern hemisphere will converge here like this. Because of Coriolis force, these winds are tilted in this direction, which we call it northeast trade winds in the northern hemisphere. And in the southern hemisphere, we have southeast trade winds. These are the southeast trade winds. The southeast trade winds start to climb up like this. When they reach at the equatorial region, what will happen? The Coriolis force at the equator is almost zero. This is a separate topic which we can discuss later. This Coriolis force will be zero at the equator, and these winds start to rise up toward the northern hemisphere. So in this region we can see that these winds have no deviation and they are just moving in the northern direction. But when these winds start to move toward the northern hemisphere, what will happen? The same Coriolis force will deviate its path like this. These winds start to climb up in the northern hemisphere in this direction. And we have discussed these were the southeast trade winds, but the direction has changed. Now we will call it southwest trade winds. And these are the winds which we call the monsoon winds. So during the month of June, these monsoon winds start to rise from the southern ocean and they begin their journey toward the equator. And when they reach at the equator, they deviate from its path and they transform into southeast trade winds to southwest trade winds, and which we call monsoon winds. Now we are going to discuss how these monsoon winds onset over the India. So this is the month of June when we have the beginning of monsoon season. From the month of March to June, the extreme low pressure will be formed here. We have the low pressure region because of the high temperature. Another low pressure region is here at the Tibetan Plateau. This low pressure region will attract the winds from the high pressure region. So where is the high pressure region? In the southern region. In the southern ocean, we have high pressure region. Why? Because the sun rays are directly falling at the Tropic of Cancer in the month of June. And in the southern hemisphere, we have winter season. And because of the low temperature, a high atmospheric pressure will be formed. So from the high atmospheric pressure, these winds start to begin their journey toward the low atmospheric pressure. So these winds, when reach at the peninsular India, the mainland India, what will happen? These winds will bifurcate into two parts. The first is the Arabian Sea branch. Then we have Bay of Bengal branch. So these are the two branches of Indian monsoon winds which will climb up toward the northern plains. So it is said that the climate of India is controlled by its topography. That means the relief features in the peninsular India and in the northern plains will control the rainfall distribution. Like we have the Himalaya region here, we have Western Ghats and Eastern Ghats. Then we have the Aravalli mountain hills in this region. These are the topographic reliefs which control the monsoon, the rainfall distribution over India. So we can see here the monsoon winds are going to collide with the Western Ghat region. Then what will happen? Suppose these are the Western Ghat mountains. And here we have Indian Ocean. These monsoon winds, the warm, moist monsoon winds, will rise up when they collide with the Western Ghats. As we move up in the troposphere, the temperature will get decreased. And because of the low temperature, these warm, moist monsoon winds will get condensed. The relative humidity will decrease. And here we have condensation process. And because of the condensation, we can see heavy cloud formation. So at the western slope of Western Ghat, we have more than 250 centimeters of rainfall. And this is why we have tropical evergreen forest at the western slope of Western Ghat. So this is windward side. But at the leeward side, these winds will start to sink down. Their temperature will increase and this will result in the very low precipitation here. So the rainfall here will be less than 60 centimeters. So here we have more than 250 centimeters of rainfall, and just behind it, behind the Western Ghat region, we have rain shadow region, and this will result in the less than 60 centimeters of rainfall. So here we have 250 centimeters of rainfall. So the Arabian Sea branch will start to collide with these mountain hills. So here we have Mahendragiri mountain hill, then we have Anaimudi, then Kudremukh, then Mahabaleshwar, Kansubai. These are the mountain ranges, mountain hills in the Western Ghat region. And as we move in the northern direction, the height of this mountain will get decreased. So here we have the rainfall of up to 270 centimeters. But at this region, we have rainfall up to 200 centimeters. So this is how the rainfall distribution we can see in the Western Ghat region. Some of the monsoon wind will start to move between the gaps of these hills. These gaps are called as ghats. And when these monsoon winds will start to move between these gaps, they will bring rainfall. So we have here the Vindhya and Satpura mountain range. So these winds, when collide with the mountain hills, here we have 150 centimeters of rainfall between these mountain hills. And at the Amarkantak region, this monsoon season will bring around 150 centimeters heavy rainfall here. So this is how the monsoon Arabian Sea branch bring precipitation in the Western Ghat region, and in the Tapi Valley and Narmada Valley, it is around 150 centimeters of rainfall. Now some of the winds will climb up toward the Kathiawar region. We have some hills here like Girnar and Gir and Girnar. These warm, moist Arabian Sea branch monsoon winds, when collide with these hills, they will bring around 200 centimeters of rainfall here. Then some of the winds will start to climb up toward the Aravali Hills. But the orientation of Aravali Hills is almost parallel to these incoming monsoon winds, and there will be no orographic rainfall we can see here. Now let's focus on the Bay of Bengal branch. When this Bay of Bengal branch start to climb up toward the northern plains, they will face first of all with the country called Bangladesh. So Bangladesh is almost a flat region. There will be no orographic rainfall here. But here we have some mountain hills. These mountain hills are called as Garo Khasi and Jaintia in the region of Meghalaya. These Garo Khasi Jaintia are welcoming these monsoon winds with a steep slope. And when the steep slope will collide with the monsoon winds, what will happen? Extreme orographic rainfall also called as forced orographic rainfall, we can see here. So this is the region near the Cherrapunji called as Meissen Ram. We can see around 1200 centimeter of rainfall in this region. So we have 200 centimeter here, around 200 centimeter in the Girnar region, then 250 centimeter at the Western Ghat region, and around 1200 centimeters rainfall at the Meghalaya hills, these Meghalaya hills. So these monsoon winds, when rise up, and they will collide with various mountain hills. So here we have Abor, Mishmi, Patkaibam. These are the mountain hills belong to the Purvanchal Himalayas. These monsoon winds will trap here and they will bring more than 200 centimeters of rainfall. And this is why we have the tropical evergreen forest in this region. So here in the northeastern region, we have 200 centimeters of rainfall. So Bay of Bengal branch now start to collide with the Himalayas. Himalayas are non-penetrable wall. When the monsoon winds will collide with the Himalayas, what will happen? They will bring huge orographic rainfall, high amount of rainfall. Just behind the Himalayas, we have rain shadow region. So here we have rain shadow. Also we have here rain shadow region. When the monsoon winds will collide with the Himalayas, this will result in the heavy rainfall. Here we have the Kosi river, the tributary of Ganga, and these tributaries swell during the monsoon season, and this will result in the heavy flood in the region of Bihar. Now, the monsoon winds now start to move toward the Thar desert. When the monsoon wind travel from West Bengal to the Rajasthan, the moisture content in these winds will start decline. So here we have rainfall of up to 200 centimeter. When this monsoon wind will reach in Bihar region, this will bring around 150 centimeter of rainfall. When these monsoon winds reach up to Allahabad, it will bring around 80 centimeter of rainfall. And then these monsoon winds collide with the Aravalli hills. Now this is the Bay of Bengal branch which bring rainfall to the eastern Rajasthan. This will result in the rainfall of up to 60 centimeter of rainfall. Here we can see 60 centimeter. And beyond the Aravalli hills, we have rain shadow region. This rain shadow region, we have less than 10 centimeter of rainfall. So this is how we have distributed the rainfall pattern around India. Now this Bay of Bengal branch start to climb up in the Jammu and Kashmir region. These are the winds which bring rainfall, or in some parts we have snowfall because of the higher altitude. We have Karakoram mountain range, and below it we have the Jaskar mountain range. When these monsoon winds collide with the Jaskar mountain range, these winds will bring rainfall to the southern slope of Jaskar mountain hills. Just beyond the southern slope, we have the rain shadow region here. So why we have rain shadow? Because of the Bay of Bengal branch winds collide with the Jaskar mountain range. This will result in the heavy rainfall. Not heavy, but moderate rainfall at the southern slope of this Jaskar mountain hills. And beyond these mountain hills, we have rain shadow region. And this is the region where we have cold desert. We call it Ladakh. So why Ladakh is dry? Because we have the rain shadow region here. But why we have cold situation there? Because of the higher altitude. So this is why we call it cold desert. So this is Ladakh region. Some of the Bay of Bengal branch winds will start to move between the gaps of these Eastern Ghat hills. Eastern Ghats are almost parallel to these Bay of Bengal branch winds. And this is why we don't see heavy rainfall in this region, especially the Tamil Nadu region. This Tamil Nadu region do not face heavy rainfall during the southwest monsoon season. Why we have these gaps? Because we have the delta here. We have Kaveri river. We have the Kaveri river here. This Kaveri river, then we have Krishna river, then Godavari river, and then we have the Mahanadi river. So this is how the peninsular India have blessed with the rivers. But what will happen when these monsoon winds will move toward these gaps? These monsoon winds will enter in these gaps like this. And here we have the Brahmagiri, from where the Kaveri river originates. At the Brahmagiri hills, these monsoon winds will collide, and this will result in the cloudburst situation. The Kaveri river will fill with water during the monsoon season, and this is why these are called as seasonal rivers. The Himalaya rivers are also called as perennial rivers because these rivers have 365 days water supply. But these are mostly depend on the monsoon season. So here we have the Brahmagiri hills. Here we have the situation of cloudburst during the month of monsoon season. Then we have the monsoon winds. These monsoon winds will enter toward the place from where the Krishna river originates. And this is the Mahabaleshwar mountain hills, where we can see cloudburst situation. Then we have these monsoon winds. When they will enter in the Godavari valley, they will collide with various mountain hills, and this will result in the heavy rainfall. So these are the region where we can see cloudburst situation in the Trimbakeshwar mountain hills. So this is how we have around 200 centimeter of rainfall in these valleys. 200 centimeter. So we have discussed about how the monsoon bring rainfall to the Indian subcontinent, and what is the different rainfall distribution across India, and how and why we have different rainfall pattern across India. So thank you.